Out there, beyond the blue sky we see every day, lies an infinite expanse of black velvet dotted with countless stars, a seemingly empty and silent void. Yet that stillness is an illusion. Earth's orbit is bustling with activity, filled with satellites, spacecraft, and, well, things no one ever expected would end up there. Some were sent with purpose, some were lost by accident, and others simply drifted into the great cosmic ocean from who knows where. And today, we're setting off on a journey to uncover 30 of the strangest, most surprising, and at times downright amusing objects currently floating through space. From a glove that slipped off an astronaut's hand to entire cars launched on whims of ambition, the stories behind these objects are as varied as they are unbelievable. What you're about to discover isn't just a list, it's a tapestry of human ingenuity, curiosity, and yes, sometimes our quirks and miscalculations, all frozen in the timeless dance of orbital mechanics. Each object tells a tale, sparks a question, and invites us to marvel at how even our smallest actions can ripple out into the cosmos. So buckle up and prepare to be surprised, amused, and maybe even left in quiet wonder. Because what's floating out there isn't just metal and plastic. It's evidence of our dreams, our experiments, and our occasional blunders, all adrift in the grand theater of space. And as we count down these 30 bizarre treasures, you might just find yourself looking up at the night sky a little differently from now on. Our journey through the cosmos begins not with a satellite or a probe, but with a simple bag of tools. It sounds almost mundane, until you consider its incredible backstory and the fact that you can, on a clear night, actually see it from your backyard. This particular tool bag entered orbit in a moment of pure, unscripted humanity high above the Earth. In 2008, astronaut Heidemarie Stefanishen Piper was conducting a routine spacewalk outside the International Space Station. Her task was to clean and lubricate a jammed rotary joint on one of the station's solar arrays. During the intricate work, a grease gun inside her toolkit malfunctioned, coating not only her tools but her gloves in a sticky, messy fluid. In the weightlessness of space, trying to clean up such a mess is a unique challenge. As she was attempting to manage the situation, the entire bag, estimated to be worth around $100,000, simply drifted away from her grasp. There was no gasp, no dramatic sound, just silent, slow-motion horror as she and her fellow astronaut watched an essential piece of their mission float serenely into the void, becoming yet another piece of space debris. NASA immediately began tracking the bag, which they officially catalogued as one more object in a growing cloud of orbital debris. But this isn't just another piece of junk. For a time, this bag became a tiny man-made star. Tumbling end over end, its highly reflective white fabric caught the sunlight just right, making it surprisingly bright. It reached a magnitude of around 6, which is right at the edge of what the naked eye can see under perfect conditions, but is easily visible with a good pair of binoculars or a small telescope. Amateur astronomers around the world actually tracked its path for months, looking for that one peculiar dot moving in a steady, silent procession across the star field. It's a haunting thought, a lost toolkit, a symbol of human fallibility, silently orbiting our planet every 90 minutes, a fleeting monument to a simple mistake made in the most complex environment imaginable. It eventually met its end, burning up in the atmosphere over the Pacific Ocean a little over a year later. But its story perfectly sets the stage for the strange catalog of items we're about to explore. If a floating bag of tools represents a moment of accidental loss, our next item is perhaps the most intentional and flamboyant piece of space debris ever created: a cherry red Tesla Roadster. This isn't a scientific probe or a piece of a space station. It's a real, working sports car, complete with a dummy in a custom spacesuit casually draped over the steering wheel, its stereo allegedly set to play David Bowie's Space Oddity on a loop. This surreal scene was launched into the cosmos on February 6, 2018, atop the first Falcon Heavy rocket built by SpaceX. The rocket's successful test flight was a monumental achievement in itself, but it was the choice of payload that captured the world's imagination. Instead of the typical concrete or steel blocks used to simulate weight for a maiden launch, SpaceX founder Elon Musk decided to send his own personal Tesla on a one-way trip to the asteroid belt. The dummy, nicknamed Starman after the Bowie song, sits behind the wheel of the convertible, his right hand permanently resting on the steering wheel, and his left arm casually perched on the door sill as if he's on a leisurely Sunday drive through the solar system. The car is locked in a heliocentric orbit, meaning it circles the Sun, not the Earth. Its trajectory takes it on a looping path that carries it just outside the orbit of Mars at its farthest point, and swings it back to a point just inside Earth's orbit at its closest approach to the Sun. As of today, the Roadster and its eternal passenger are millions of miles away, having completed multiple laps around our star, silently cruising through the void. Beyond the sheer spectacle, the stunt was a masterclass in public relations and a bold statement about the future. It was a powerful demonstration of the Falcon Heavy's capability to launch heavy payloads into deep space, all wrapped in a package that was undeniably cool and infinitely shareable. It blurred the lines between corporate achievement, artistic expression, and viral marketing. For a brief moment, space exploration felt less like a distant government endeavor and more like something accessible, adventurous, and even fun. The image of that red car against the blackness of space, with the Earth as a stunning blue marble in the background, became an instant icon. It's a bizarre time capsule, a piece of pop culture hurtling through the solar system. Long after the car's batteries have died and its paint has been bleached by relentless solar radiation, Starman's joyride will continue, a silent testament to a moment when humanity decided to send a little bit of whimsy to the stars. Moving from the whimsical to the truly wondrous, our next object isn't something humanity launched, but a breathtaking sculpture crafted by the universe itself. Drifting approximately 900 light-years away in the constellation Orion is a cosmic cloud of gas and dust known as the Witch Head Nebula. Its official, less poetic name is IC 2118. From our vantage point on Earth, this vast nebula already presents a haunting profile. Its faint, blue glow eerily resembling the hooked nose and sharp chin of a storybook witch staring across the cosmos. But nestled within this celestial portrait is an even more striking feature. A long, slender, and remarkably straight pillar of dust that looks for all the world like a broom caught mid-sweep, as if the cosmic witch herself is clearing a path through the stars. This isn't a solid object, of course, but an incredibly dense lane of interstellar soot and gas. A dark nebula silhouetted against the brighter material behind it. The sheer scale is almost incomprehensible. This celestial broomstick is light years long. Its formation is a masterclass in cosmic forces. The entire Witch Head Nebula is what astronomers call a reflection nebula. Unlike nebulae that glow with their own light from energized gas, a reflection nebula does exactly what its name implies. It reflects the light from nearby stars. In this case, the brilliant, intense light is coming from Rigel, a blue supergiant that is the left foot of the Orion constellation and one of the brightest stars in our night sky. Rigel is a stellar powerhouse, burning ferociously hot and emitting a tremendous stellar wind, a constant, supersonic stream of charged particles flowing out from its surface. For eons, this relentless wind has been blowing against the Witch Head Nebula, a much colder and slower-moving cloud. The result is a process akin to erosion on an interstellar scale. The powerful stellar winds have sculpted and compressed the nebula's material, pushing the finer dust and gas away and leaving behind more resilient structures. The broom we see is essentially a cosmic sandbar, a dense ridge of material that has resisted being swept away. standing in stark relief as the lighter matter around it is continually blasted by Rigel's energetic output. What makes this structure so captivating is its fleeting nature. In the grand timeline of the universe, this precise formation is just a momentary snapshot. The relentless pressure from Rigel's wind is constantly reshaping the nebula, meaning that over thousands of years, the broom's handle may warp, its bristles may dissipate, and the entire eerie visage of the witch will slowly morph into something new. We are witnessing a single frame in a supremely slow-motion movie of creation and destruction. It serves as a powerful reminder that the cosmos is not a static museum display but a dynamic, ever-changing workshop, where even the most ghostly and permanent-looking structures are merely temporary artworks in an infinite gallery. While a floating tool bag represents a modern mishap, one of the very first pieces of space junk dates back to the earliest days of American spacewalking and is arguably one of the most personal items ever lost: a single glove. During the Gemini 4 mission in June 1965, astronaut Ed White made history by performing the United States' first ever extravehicular activity, or spacewalk. Tethered to the spacecraft and armed with a handheld gas-powered gun called a zip gun for maneuvering, White spent 23 minutes floating above the Earth, a moment of pure exhilaration and national pride. As the mission neared its end and Commander James McDivitt instructed him to get back into the spacecraft, White famously expressed his reluctance, calling it the saddest moment of his life. In the process of maneuvering his bulky, pressurized suit back into the cramped cabin, a single glove inadvertently slipped free from his grasp. In the weightless environment, the glove didn't fall, it simply drifted away, becoming an instant and silent artifact of human exploration. NASA began tracking the glove, which joined the tool bag as an early piece of cataloged space debris, designated with its own number. For months, it orbited the Earth, a solitary sentinel from one of humanity's most ambitious steps into the cosmos. Unlike the tool bag from the International Space Station, which orbited at a relatively low altitude and re-entered the atmosphere fairly quickly, the glove from Gemini 4 was left in a slightly higher orbit. Its fate, however, was ultimately the same as most objects in low Earth orbit: a fiery demise. The prevailing and most scientifically sound theory is that the glove eventually succumbed to atmospheric drag. Over time, even the tenuous wisps of gas in the upper atmosphere exert a tiny but constant force on objects, slowly sapping their orbital energy. After about 1 month, the glove's orbit decayed enough that it dipped into the thicker layers of the atmosphere. There, traveling at thousands of miles per hour, it would have encountered immense friction and heat, causing it to incinerate completely in a brief, silent streak of light, a meteor of human making. However, this being one of the first strange objects lost in space, a small shadow of mystery persists. The exact timing and location of its re-entry weren't pinpointed with the precision we have today, leading to a fringe but fascinating possibility that it might not have burned up entirely. Could a charred, mangled remnant of the glove have survived the intense heat and actually made it to the ground? It's an incredibly remote chance, but the idea captures the imagination. Somewhere, perhaps in a remote desert or at the bottom of an ocean, a piece of that historic mission could theoretically be resting, waiting to be found. This tiny sliver of doubt transforms the glove from a simple piece of lost equipment into a potential treasure, a relic from the dawn of spacewalking that might have miraculously returned home. It serves as a poignant reminder of those first, precarious steps into the void, where every procedure was new and even gripping the handrail was a learned skill. That lost glove symbolizes both the incredible achievement of Ed White's walk and the inherent vulnerability of early spaceflight, a single human-scale item adrift in the immense blackness. Now, if the stories of lost gloves and sports cars show our accidental and intentional marks on the cosmos, our next item takes us into the realm of pure mystery, a tale that has captivated conspiracy theorists and space enthusiasts for decades. It's the legend of the Black Knight satellite, an object said to be an alien probe from a distant star system, silently watching over Earth for 13,000 years. The story is a compelling mix of misunderstood science, historical fragments, and outright fiction, all woven together into one of space's most enduring myths. The lore suggests this ancient, artificial satellite has been orbiting our planet since before human civilization began, its origins and purpose completely unknown, a silent sentinel from the stars. But the truth behind the legend is, in many ways, just as fascinating as the fiction. The origins of the Black Knight story are a patchwork quilt of different events, each one misinterpreted or taken out of context. One of the earliest threads dates back to the late 19th century and the pioneering work of Nikola Tesla. In 1899, while experimenting with his high-voltage radio transmitter in Colorado Springs, Tesla believed he had detected a strange, repeating radio signal that seemed to be coming from space itself. He theorized it might be an attempt at communication from Mars or another intelligent civilization. While this was a reasonable hypothesis for the time, modern science attributes what Tesla heard to natural phenomena, like radio emissions from Jupiter or even pulses from a distant pulsar, a type of rotating neutron star that had not yet been discovered. The next major chapter in the myth arrived in the 1920s with reports of a Norwegian engineer named Jørgen Hals. He found that his own radio transmissions were being echoed back to him after unusually long delays. These long-delayed echoes were a genuine scientific curiosity, but they were eventually explained by the way radio waves can bounce between different layers of Earth's ionosphere, not by an alien object retransmitting the signals. The legend truly crystallized in the 1960s during the early days of the space race. Articles appeared in American newspapers like the St. Louis Post-Dispatch and Time magazine mentioning a mysterious, dark object in a polar orbit. This was not a UFO, but rather the discovery of a top-secret American spy satellite program called Corona, or its Discoverer capsule, which the U.S. government had not yet publicly acknowledged. To the public, however, it seemed like the military had discovered something unknown and was keeping it quiet. The name Black Knight itself was likely borrowed from a British rocket program of the same name, adding another layer of confusion. But what about the famous, ominous photographs? The most iconic image associated with the Black Knight is a dark, irregular shape set against the curve of the Earth, often presented as proof of the alien object. This photo is perhaps the biggest piece of evidence, and it is completely real. It was taken in 1998 during a Space Shuttle Endeavour mission to the International Space Station. So what is it? It's not an alien spacecraft from a forgotten age. It's a thermal blanket. During an earlier spacewalk, astronauts had been installing equipment and lost a piece of protective black insulation. It was simply a piece of human-made space junk, briefly orbiting near the shuttle before it drifted away or eventually fell back to Earth. The image is genuine, but its explanation is mundane. Today, the various objects that have been labeled the Black Knight over the decades are understood by astronomers and space agencies to be a combination of identified space debris, discarded rocket parts, and the occasional lost piece of equipment like that thermal blanket. There is no single, mysterious object matching the description. The myth persists because it taps into a deep and fundamental human desire, the hope that we are not alone, and that evidence of other intelligent life is hiding in plain sight, just waiting for us to discover it. The Black Knight is a phantom, a story we built from the shadows of our own technology and the vast, unknown nature of space. It's a cultural artifact, a modern legend that continues to orbit not in the sky, but in our collective imagination. But while myths like the Black Knight capture our imagination, some of the most genuinely surreal phenomena in orbit are not alien at all. They are the direct and somewhat uncomfortable result of basic human biology meeting the unforgiving physics of space. This brings us to one of the most peculiar and transient forms of space debris ever created: the fleeting, glittering clouds of urine ice crystals. This process begins with the complex reality of going to the bathroom while wearing a spacesuit during a multi-hour spacewalk, officially known as an extravehicular activity or EVA. Inside a modern spacesuit is a specialized undergarment called the maximum absorbency garment, which is essentially a highly advanced, multi-layered diaper designed to handle both solid and liquid waste. However, the systems for managing liquid waste on earlier missions, particularly during the Space Shuttle era, were a bit more direct. The Shuttle-era spacesuits were equipped with a device called the Disposable Absorption Containment Trunk, which included a plastic urine collection bag that could be emptied. But there was no tank to store the waste. The only way to get rid of it was to vent it directly overboard into the vacuum of space. So, when an astronaut needed to relieve themselves during a long spacewalk, the resulting liquid would be released through a special valve on the suit. The moment that stream of urine exits the suit, it enters an environment of pure emptiness, with almost zero atmospheric pressure and temperatures hovering hundreds of degrees below zero. In that instant, a rapid and incredible physical transformation occurs. The water content within the urine doesn't just slowly freeze, it undergoes immediate sublimation. This means the liquid particles flash freeze directly from a liquid into a solid, completely skipping the liquid phase, and then many of those solid crystals immediately vaporize into a gas. The result is an expanding, glittering cloud of countless tiny ice crystals shooting away from the astronaut. Each crystal catches the intense, unfiltered sunlight, creating a temporary, brilliant spectacle that resembles a miniature comet tail or a firework bursting in slow motion. For a few moments, the astronaut is surrounded by their own personal nebula, a cloud of frozen waste sparkling with impossible beauty against the profound blackness of space. These crystals don't just hang around, they enter their own independent orbit, traveling at the same incredible speed as the astronaut and the space station, roughly 17,500 miles per hour. They form a short-lived ring of glittering particles that gradually disperse. Their fate, however, is always sealed. Whether they sublimate completely into gas or their orbit slowly decays, these tiny crystals are destined to be drawn into the upper atmosphere. There, they incinerate harmlessly, adding an almost poetic, if slightly bizarre, footnote to the journey of human waste. It briefly becomes a starry spectacle before burning up as a meteor. This phenomenon is more than just a strange orbital fact. It represents the raw, unfiltered challenge of supporting human life in an environment that is utterly hostile to it. Every single biological process we take for granted on Earth, eating, sleeping, even going to the bathroom, requires incredibly complex and often inelegant engineering solutions to manage in microgravity. The glittering urine cloud is a visceral, undeniable reminder that human explorers in space are fragile biological entities in a realm of extreme physics. It's a blend of the profoundly advanced and the utterly primitive, where multi-million-dollar cutting-edge suits have to account for the most basic bodily functions. These temporary artificial comets are perhaps the most human of all the debris we've created, a fleeting and beautiful testament to the messy, biological reality of life among the stars. Yet the ethereal beauty of a human-made comet is fleeting and small in scale. But our next phenomenon is a spectacle of truly cosmic proportions, one that has occasionally painted the night sky with a phantom that both mystifies and terrifies unsuspecting witnesses. This is the story of the so-called space jellyfish, a breathtaking and utterly surreal display of light that occurs not from a biological process, but from the final, dying breaths of a rocket. The journey of a rocket into space is a violent, controlled explosion, a multi-stage process where massive fuel tanks and powerful engines are used and then discarded to shed weight. Once a rocket's upper stage has finished its burn and delivered its payload, a satellite or a capsule, into the correct orbit, its job is done. But it doesn't just become a silent, inert piece of metal. Tanks that once held supercooled liquid fuels like liquid oxygen or hydrogen are now empty. But they are not truly empty. They contain residual fuel and pressurized gas. In the vacuum of space, the sun's intense heat warms the metal skin of these spent stages. This heating causes the remaining fluids inside to boil, and the internal pressure to rise dramatically. To prevent the entire stage from exploding catastrophically, which would create a dangerous cloud of shrapnel, the rocket is equipped with specially designed vent valves. These valves open automatically, releasing the pent-up pressure and remaining fuel vapors in a controlled, safe manner. When this venting occurs, the results are nothing short of magical. The released fuel, often water vapor from the combustion process or unused propellant, instantly flash freezes into a massive, expanding cloud of countless billions of microscopic ice crystals. This cloud can be enormous, sometimes stretching for miles across. The true magic happens when this newly formed cloud of ice drifts into the sunlight, just after sunset or before dawn for observers on the ground below. While the Earth's surface is shrouded in darkness, these high-flying crystals are still bathed in the full, brilliant light of the sun, which is just below the horizon from our perspective. The crystals act like a countless array of tiny mirrors and prisms, catching and reflecting the sunlight with incredible efficiency. To a person standing on a dark stretch of Earth, looking up at the twilight sky, the effect is staggering. What they see is a luminous, ethereal shape that appears to pulse and grow. It often has a bright, condensed head, the still visible rocket body, followed by a vast, shimmering, and slowly undulating veil of light that can glow with an eerie blue-white or even golden hue. Its amorphous, flowing form bears an uncanny resemblance to a giant, celestial jellyfish drifting silently through the upper atmosphere. This spectacle has been the source of more than a few UFO reports and panic-induced phone calls to authorities. For those unaware of the scientific explanation, the sight of a glowing, pulsating, and seemingly intelligent organism in the sky can be deeply unsettling. But the reality is a beautiful demonstration of orbital mechanics and simple physics. The jellyfish is a temporary monument to human engineering, a final artistic flourish from a machine that has completed its purpose. It is a cloud that has never known an ocean, a ghost made of ice and light, a brief and stunning signature written across the sky to mark humanity's continued reach into the cosmos. While a glittering cloud of frozen waste represents the challenges of human biology in space, and the awe of a space jellyfish comes from the death of a machine, our next object is a stark reminder of the high-stakes precision required for orbital repairs, and how a single, simple mistake can have permanent consequences. It's a tool, a standard, 2-foot-long precision torque wrench known as a pistol grip tool, that was lost during a delicate and critical operation, fixing the Hubble Space Telescope. The incident occurred in 2007 during the complex STS-124 Space Shuttle mission, a flight dedicated entirely to servicing and upgrading the iconic orbital observatory. Astronaut Scott Parazynski was working at the end of the shuttle's robotic arm, which had been extended to position him near one of Hubble's equipment bays. He was in the process of installing a new scientific instrument, the Cosmic Origins Spectrograph, a painstaking task that required immense focus. The pistol grip tool is a sophisticated, battery-powered device designed to provide astronauts with exact levels of torque to securely fasten or remove bolts without damaging the sensitive equipment. As Parazynski was maneuvering the tool, preparing to hand it off to a fellow astronaut, it simply slipped from his grip. In the microgravity environment, there was no clatter, no fall, just the silent, heart-sinking sight of a vital, million-dollar piece of equipment drifting serenely away from the workspace, tumbling end over end into the void. NASA ground controllers immediately began tracking the object, officially cataloging it as another piece of orbital debris. But this was no ordinary piece of junk. This screwdriver, weighing just under 1.5 pounds, was now an unguided projectile traveling at approximately 17,500 miles per hour. At that staggering velocity, even a tiny fleck of paint can pit the reinforced glass of the space shuttle's windshield. An object the size and mass of this tool carries the kinetic energy equivalent to a much larger, destructive force. It instantly became classified as potentially hazardous debris, a threat not only to the shuttle and Hubble for the remainder of that mission, but to every other spacecraft and satellite sharing similar orbital space. The screwdriver joined a growing cloud of over 500,000 pieces of debris, currently being tracked by space agencies around the world. Each one is a bullet waiting for a target, and a collision with even a small object could be catastrophic, capable of disabling satellites, puncturing modules of the International Space Station, or endangering future missions. This particular tool, due to the high altitude of the Hubble servicing mission, was left in a relatively stable orbit. Unlike objects closer to Earth that are slowly pulled down by atmospheric drag, debris at Hubble's altitude of around 350 miles can remain in space for decades. This lost screwdriver is expected to continue its silent, high-speed journey around our planet for many years to come, a perpetual monument to a single moment of human error during one of NASA's most ambitious and successful repair missions. It serves as a constant, sobering reminder that in the unforgiving environment of space, every action has a lasting reaction, and every tool, no matter how small, must be handled with the utmost care. From the precision-engineered chaos of a lost tool, we now turn our gaze to a structure of such immense natural artistry that it seems to defy explanation, a celestial instrument strummed by the forces of creation itself. Drifting in the constellation Cepheus, approximately 2,300 light-years from Earth, is an object officially catalogued as IRAS 20324+4057. But to the astronomers who discovered its unique shape, it is known far more poetically as the Guitar Nebula. This isn't a cloud of gas passively waiting to form stars. It is a pulsar wind nebula, a dynamic and powerful testament to the death of a star and the incredible energies it continues to unleash. At the heart of this cosmic guitar is the pulsar B2224+65, a city-sized, spinning stellar corpse. Pulsars are the ultra-dense, rapidly rotating neutron stars left behind after a massive star goes supernova. This particular pulsar is a cosmic speedster, rocketing through the interstellar medium, the thin gas and dust between stars at an astonishing speed of over 800 miles per second. To put that incomprehensible velocity into perspective, it's moving fast enough to travel the distance from Earth to the Moon in less than 10 minutes. As it tears through space, it behaves like a supersonic jet plane plowing through the atmosphere, but on an interstellar scale. The pulsar generates a fierce, continuous wind of high-energy particles and magnetic fields that streams away from it at nearly the speed of light. This relentless wind slams directly into the slower-moving interstellar gas ahead of the pulsar, and this collision is what sculpts the nebula's breathtaking form. The result is a gigantic, bow-shaped shockwave, much like the wave that forms at the prow of a speeding boat. This glowing bow shock forms the guitar's distinctive and rounded body. But the true magic, the feature that gives this nebula its name, trails behind this speeding star. The pulsar's intense particle wind, channeled by its powerful magnetic fields, is flowing outward most freely from its magnetic poles. This creates two narrow, focused jets of energy that are stretching back into the wake of the pulsar's journey. These jets, composed of energized matter, form the nebula's long, straight neck and strings, stretching for an incredible 5 light-years across space. We are witnessing a feedback loop of cosmic power. The pulsar's rapid rotation and intense magnetic field accelerate particles to near light speeds, creating the wind that inflates the nebula. The shape of that nebula is, in turn, dictated by the pulsar's breakneck speed through the galaxy. It is a perfect snapshot of motion and energy frozen in time and glowing gas. The entire structure is a temporary phenomenon. The pulsar will continue its relentless journey, eventually leaving this particular cloud of interstellar material behind. The guitar will slowly fade and dissipate, its strings vanishing as the pulsar moves into a region of space with less material to plow through. For now, however, it remains one of the most visually striking and clear examples of a bow-shock nebula ever observed, a natural sculpture that resonates with the fundamental physics of our universe. It's a haunting and beautiful reminder that the cosmos is not silent. It is filled with the music of moving masses and energetic particles, a symphony written in the language of light, where a dying star plays a final, unforgettable chord on an instrument 5 light-years wide. But for all the high-tech gear and sophisticated tools that astronauts use, some of the most heartbreaking and expensive losses have come from the simplest of devices, the camera. Capturing the incredible view from space is a core part of every mission, but in the unforgiving void, holding onto that hardware is a constant challenge. Over the decades, several astronauts have experienced that gut-wrenching moment of watching thousands, and sometimes millions, of dollars worth of photography equipment silently tumble away into the infinite black. One of the earliest and most famous instances involved a Hasselblad camera, the workhorse of NASA's lunar missions. During the Gemini 10 flight in 1966, astronaut Michael Collins was tasked with a spacewalk to retrieve a micrometeorite detection package from an earlier, unmanned Agena rocket. As he maneuvered outside the capsule, a Hasselblad 500C camera specially modified for space use became untethered and drifted away. Collins later wrote about the moment with a mix of humor and frustration, calling it a dumb mistake, and noting that the camera, with its precious film inside, was likely destined to orbit the Earth for a few months before burning up. That single lost camera represented not just a significant financial loss, but the irrevocable loss of unique photographic history. The tradition of losing cameras, unfortunately, did not end with the Gemini program. Perhaps the most costly single piece of photographic space junk was lost during the first Space Shuttle mission, dedicated to assembling the International Space Station in 1998. Astronaut Jerry Ross was conducting a spacewalk from the shuttle Endeavour when a very specific and expensive tool slipped from his grip. It wasn't a wrench or a screwdriver this time, it was a $60,000 photogrammetric camera. This was no ordinary point-and-shoot. It was a specialized, calibrated instrument designed to take precise measurements from photographs, crucial for ensuring the proper alignment of the massive station components being installed. One moment it was in his hand, the next it was just gone, becoming an instant and very pricey piece of orbital debris. Its fate was to circle the planet until atmospheric drag eventually pulled it down to a fiery end. Even in the modern era, with more secure tethers and protocols, these accidents still occur. In 2007, during another spacewalk, astronaut Scott Parazynski, the same astronaut who later lost the torque wrench at Hubble, was also involved in an incident where a spare camera floated away. This time, it was a digital camera that was being stored on a tool caddy. The caddy's latch apparently failed, and the camera simply drifted off into space, lost forever. Each of these events serves as a stark reminder of the relentless physics at play. In microgravity, there is no down for an object to fall to. Anything that isn't secured will simply float away, and even the tiniest push or nudge can impart enough velocity to separate it from the astronaut or spacecraft permanently. These lost cameras now form a ghostly gallery of failed captures, each one representing a set of images that will never be seen. A perspective on the cosmos that was gained for a moment, and then lost for all time. They are silent, tumbling monuments to the human desire to document the incredible, and the profound difficulty of holding onto anything in the void. While lost cameras capture moments that might have been, Some of the most persistent and ghostly objects in orbit are those that were never meant to be seen again at all. These are the expended rocket bodies, the hollowed-out shells of launch vehicles that have fulfilled their purpose and been cast adrift. Once the fiery thrust of their engines ceases, these massive metal cylinders become inert, tumbling slowly end over end in the silent darkness. But in their death, they often create a strange and eerie second life, transforming into celestial specters that have fooled countless observers into reporting unidentified flying objects. The phenomenon begins with their rotation. As a spent rocket stage tumbles, its surface, often polished metal or reflective thermal coating, catches the sunlight at constantly changing angles. For an observer on the ground with a telescope, this creates a rhythmic, pulsating flash, a slow-motion strobe light moving in a perfectly straight line against the backdrop of stars. This regular flashing is a classic signature of human-made space debris, but to the untrained eye, it can appear utterly unnatural. The illusion becomes even more convincing when the rocket body is in a state known as attitude drift, where its tumble gradually slows down. As the rotation decays, the flashing can become more erratic and unpredictable, sometimes pausing for long periods before resuming. This unpredictable behavior breaks the familiar pattern of satellites and can make the object seem under intelligent control, as if it's hovering or maneuvering. Furthermore, many of these rockets still hold residual fuel in their lines or tanks. Just like the stages that create space jellyfish, these remnants can slowly vent into the vacuum, creating a temporary, faint haze of gases or ice crystals around the main body. When illuminated by the sun from just the right angle, this ethereal cloud can make the rocket stage look like a luminous, fuzzy orb or a misty, undefined shape, further obscuring its true identity and feeding into tales of phantom craft. Perhaps the most famous example of a rocket body masquerading as something more sinister is the story of the Black Knight satellite, a myth we touched on earlier. The core of that legend was almost certainly fueled by sightings of a real object, a discarded payload fairing or an Agena rocket body from the early American space program, tumbling in a polar orbit. Its path took it over regions unaccustomed to seeing satellites in the 1950s and 60s, and its unusual flashing light pattern sparked imaginations and fears of a silent alien watcher. Even today, with detailed databases of orbiting objects available to amateur astronomers, these ghost rockets continue to generate reports. A slow-moving, bright light that pulses mysteriously and doesn't match the predictable path of a known satellite is a recipe for a UFO call to local news stations. These phantom stages are more than just optical illusions. They are a tangible part of the space debris problem. Each one is a multi-ton, uncontrolled object on a chaotic path, a potential source of thousands of new debris fragments if it were to collide with anything else. They serve as silent, tumbling tombs for the ambitions that launched them, each one a monument to a mission accomplished but now forgotten. Their eerie light show is a byproduct of their material existence in an environment of extreme light and shadow, a reminder that even our most advanced machinery, once its task is done, can become a ghost in the celestial machine, reflecting our own technological presence back at us in the most mysterious and unsettling ways. While countless objects in orbit tell tales of accident or exploration, one of the most peculiar items was placed there with the explicit, audacious goal of preserving humanity itself. Attached to the exterior of the Columbus module on the International Space Station is a small, unassuming device with a grand and almost mythological name: the Immortality Drive. This isn't an official NASA or ESA experiment. It was the brainchild of a private company called Odyssey Atlantis as part of a project called One Giant Leap, and its purpose was to create a modern-day Noah's Ark, but for human information rather than living creatures. The drive itself is a commercial, solid-state computer memory unit, specifically chosen for its ability to withstand the extreme temperature fluctuations and radiation of space. But its contents are what truly set it apart from any other piece of hardware on the station. Inside that radiation, hardened casing are the complete digital DNA sequences of a select group of individuals, a genetic blueprint that could, in theory, be used to reconstruct them far in the future. Among the first contributors were some of the brightest minds and most influential personalities of our time, including the renowned theoretical physicist Stephen Hawking and the comedian and television host Stephen Colbert. The idea was to safeguard the genetic code of humanity's great achievers against any potential planetary catastrophe on Earth, ensuring that their unique intellectual and cultural legacy wouldn't be completely lost to the universe. It's a concept ripped from science fiction, a real-life attempt to create a backup of human genius in the ultimate off-site storage facility, low Earth orbit. The project, however, was met with significant controversy and skepticism from the scientific community. Critics were quick to point out the immense practical challenges. DNA, even in digital form, degrades over time. The solid-state memory itself has a finite lifespan and is susceptible to cosmic radiation damage that could corrupt the data it's meant to protect. Furthermore, the idea that this data could be used to physically reconstruct a person is a monumental leap. Sequencing a genome is one thing, but having the instructions is a far cry from having the technology, the biological building blocks, and the surrogate environment necessary to actually create a living, breathing human being. It presupposes a future civilization advanced enough to read the data and execute the unimaginably complex task of de novo human synthesis, yet one that somehow lost all other records of our species' achievements and needed this specific genetic library to rediscover them. Beyond the practicalities, the endeavor raised profound ethical questions. Who gets to decide which human genomes are worthy of preservation for all eternity? The selection of a handful of predominantly famous figures presents a very specific, and some would argue narrow, vision of human value. It edges uncomfortably close to a form of genetic elitism, suggesting that some DNA is more worthy of saving than others. Despite these weighty criticisms, the immortality drive remains a powerful symbol. It represents a very human impulse, not just to survive but to be remembered. It's a gesture of hope cast into the void, a message in a bottle sent to the future, declaring that we were here, we achieved great things, and we mattered. It may be more philosophical experiment than practical solution, but as it orbits silently above us, it serves as a permanent, if quirky, monument to our species' boundless ambition and our deep-seated fear of being forgotten. While we've explored objects we've placed in orbit and phenomena born from our own technology, some of the most profound mysteries are simply passing through, visitors from the vast expanses between the stars. The discovery of these interstellar objects has completely rewritten our understanding of our solar system's place in the cosmos, suggesting that the traffic of material between star systems is far more common than we ever imagined. It all began in October 2017 when astronomers in Hawaii spotted something unprecedented using the Pan-STARRS telescope. They detected a faint, fast-moving object on a trajectory so extreme it could only mean one thing: it was not from here. This was no asteroid or comet from our own solar system. Its hyperbolic orbit indicated it was a traveler from another star, simply cutting through our neighborhood on its endless journey through the galaxy. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. What made Oumuamua so instantly captivating was its utterly bizarre set of characteristics. Initial observations suggested it was highly elongated, shaped something like a cigar or a pancake, with estimates suggesting a length up to 10 times its width, proportions unlike any known asteroid or comet in our solar system. As it hurtled away from the Sun, something even stranger happened. It exhibited a slight but undeniable non-gravitational acceleration, meaning it was speeding up in a way that couldn't be explained by the gravitational pull of the Sun or planets alone. For comets, This kind of acceleration is common and is caused by outgassing the sun's heat vaporizing ice on the surface, creating jets of gas that act like tiny thrusters. But Oumuamua showed no visible coma, the classic cloud of gas and dust that surrounds a comet's nucleus. It appeared as a dry, rocky object, yet something was pushing it. This combination of mysteries, its unusual shape, its lack of a visible coma, and its inexplicable acceleration, ignited a firestorm of speculation in the scientific community and beyond. The most tantalizing, though highly controversial, theory came from Harvard astronomer Avi Loeb, who suggested we must at least consider the possibility that Oumuamua was not a natural object, but a piece of advanced alien technology. He proposed it could be a light sail, a thin, reflective sheet designed to be pushed by the radiation pressure from stars, which would explain its unusual acceleration without any visible outgassing. While most astronomers favor natural explanations, such as it being a rare fragment of a Pluto-like planet from another system or releasing hydrogen gas that telescopes couldn't detect, the very fact that such a wild hypothesis could be seriously debated highlights how truly peculiar this visitor was. Oumuamua left us with more questions than answers, a silent, tumbling enigma that we detected too late to study in detail, forever leaving us to wonder about its true nature. Since Oumuamua's dramatic passage, we have confirmed a second interstellar visitor, Comet 2I/Borisov, which arrived in 2019. In stark contrast to its predecessor, Borisov behaved exactly as scientists expected an interstellar comet would, displaying a prominent coma and tail as it swung around the sun. Its familiar cometary activity was almost a comfort, proving that other star systems have comets much like our own. But the door Oumuamua opened is now permanently ajar, and astronomers are actively searching for more of these interstellar interlopers. Projects like the Vera C. Rubin Observatory, set to come online in the next few years, are expected to find dozens, if not hundreds, of such objects, transforming them from extraordinary rarities into a new class of celestial body for routine study. The existence of these travelers reveals a universe that is far more dynamically connected than we once believed. Material is constantly being exchanged between planetary systems, ejected by gravitational interactions with giant planets, or during the chaotic formation of solar systems. It's plausible that Earth itself has been seeded with organic compounds from such interstellar vagabonds over its long history. Every one of these objects is a priceless sample from a world we may never visit directly, a capsule containing the raw ingredients of a planet that formed around another sun. They offer us a unique opportunity for comparative planetology on a galactic scale, allowing us to literally hold a piece of another star system in our observational crosshairs and ask fundamental questions about whether the processes that shaped our solar system are universal or unique. The next Oumuamua might already be on its way, and next time, we intend to be ready, with telescopes trained and perhaps even spacecraft missions planned to intercept it, hoping to finally get a close-up look at a messenger from another star. While astronauts are tethered to their spacecraft by safety lines, the tools and platforms they use to secure themselves while working are not always so lucky. Among the most critical pieces of equipment for any spacewalk are foot restraints, often called golden slippers for their color, and larger work platforms. These devices are essential for allowing an astronaut to anchor themselves to the shuttle or station, freeing both hands for complex tasks. But in the microgravity environment, where even a gentle push can send an object drifting away, these very platforms of stability have sometimes become unstable themselves, breaking free to become silent, tumbling hazards. One notable incident occurred during a space shuttle mission in the 1990s. An astronaut was working with a portable foot restraint, a device that clamps onto various handrails and structures outside the vehicle. During the process of relocating it to a new work site, the clamping mechanism was not fully secured. A slight bump or an inadvertent tug was all it took for the restraint to release its grip. In the slow-motion reality of space, the astronaut could only watch as the vital piece of equipment, worth tens of thousands of dollars, silently pivoted and began a slow, steady drift away from the workspace, becoming an instant and permanent addition to the orbital debris field. The danger posed by these lost items is significant and twofold. First, there is the immediate risk to the ongoing mission. A foot restraint or a work platform is a substantial piece of metal, often with protruding edges and clamps. Traveling at orbital velocities of over 17,000 miles per hour, a collision with the spacecraft, the station's solar arrays, or even an astronaut's suit could be catastrophic. The second, longer-term risk is to the orbital environment itself. These objects are lost in some of the most valuable and heavily trafficked regions of low Earth orbit, the same altitude bands occupied by the International Space Station, the Hubble Space Telescope, and countless vital satellites. Each new piece of debris, no matter its size, adds to the cloud of shrapnel that threatens all space operations. Perhaps the most famous example of a major lost platform is the EVA-RESC, U-Assist Aid, a larger contraption designed as a potential brace to help a crew member maneuver an incapacitated astronaut back to the airlock. During a shuttle flight in the early 2000s, one of these aids was being moved outside the payload bay when it was accidentally released. The platform, roughly the size of a large suitcase, drifted away and joined the growing catalog of tracked debris. Its orbit was initially very similar to that of the shuttle and space station, making it a persistent concern for trajectory planners on the ground who had to ensure subsequent missions would not have a close encounter with the very equipment designed to save them. The fate of these rogue platforms is a slow decay. Gradually, over months or years, the tenuous drag of the upper atmosphere will sap their energy, pulling them down to a fiery demise. But during their operational lifetime, they serve as constant, silent reminders of the challenges of working in space. Every procedure, no matter how routine, carries an element of risk. A moment of distraction, a latch not quite fully closed, or a mechanism worn from repeated use can result in the permanent loss of critical hardware. These glinting, tumbling work platforms are more than just junk. They are monuments to the immense difficulty of performing precise, mechanical work while floating in a vacuum, where every action requires a conscious counter-reaction, and there is no gravity to lend a helping hand. Yet even astronauts working outside have the relative comfort of their pressurized suits. The spacecraft itself must maintain a fragile, life-giving bubble of air against the absolute vacuum of space. This delicate balance can sometimes be breached by the tiniest of holes, leading to one of the most visually stunning and ethereal forms of space debris: the temporary, cathedral-like ice formations created by leaking water. These aren't accidents of lost equipment, but rather byproducts of the station's complex life support systems, which regularly produce water vapor as a result of processing air and human waste. Occasionally, through a minute crack in an external coolant line or a small seal failure, this water can escape into the void. The moment it meets the vacuum, a breathtaking transformation begins. The water doesn't simply freeze into a solid block. In the absence of atmospheric pressure, it undergoes rapid flash freezing and sublimation simultaneously. This process creates a chaotic yet strangely ordered dance of physics. As the water vapor expands into the vacuum, it immediately crystallizes into countless tiny ice particles. But these crystals don't just sit there. Many of them instantly turn right back into a gas, skipping the liquid phase entirely. This violent cycle of freezing and vaporizing acts as a natural sculptor. The escaping vapor pushes and carves the forming ice, while the extreme cold of space locks each delicate tendril into place. The result is not a simple icicle, but an incredibly complex, fractal structure that grows and evolves in real time. It can form delicate, feathery fronds, intricate lattices that resemble Gothic stonework. and vast, curved arches that look like the vaulted ceilings of a grand cathedral, all spun from the purest, most transparent ice imaginable. These ephemeral sculptures are backlit by the most powerful light in the solar system, the unfiltered sun. As the structure grows, sunlight refracts and scatters through its countless crystalline facets, making the entire formation glitter and sparkle with an intense, brilliant white light. It becomes a chandelier of unparalleled scale, hanging against the profound blackness of space. For the astronauts inside the station, spotting one of these formations growing on an exterior panel is a moment of both concern and awe. It signals a leak that engineers on the ground need to trace and address, but it also presents a spectacle of surreal beauty that no human artist could ever hope to replicate. The intricate patterns are a direct physical manifestation of the complex physics at play, a perfect, natural experiment in thermodynamics and fluid dynamics playing out in slow motion. But like all things in the harsh environment of space, its beauty is tragically fleeting. The same sunlight that makes it glow also seals its fate. The intense solar radiation provides enough energy to dramatically accelerate the sublimation process. The entire intricate structure, which may have taken hours to form, can vanish in a matter of minutes, transforming from a solid, glittering palace into an invisible cloud of water vapor that dissipates into the void. It leaves behind no trace, no evidence of its existence except for the memories and photographs of those fortunate enough to have witnessed it. These floating cathedrals of ice are perhaps the most poetic form of space debris. They are born from the essential systems that keep humans alive in orbit, sculpted by the unforgiving laws of physics into a form of breathtaking, temporary art, and then gently erased by the very star that gives them light. A silent and beautiful cycle of creation and destruction repeated on the silent stage of space. But for all the tools and hardware lost overboard, some of the most scientifically devastating losses involve not the equipment itself, but the priceless, irreplaceable data it was meant to collect. The International Space Station is, first and foremost, a world-class laboratory, a unique platform for conducting experiments in microgravity that are impossible on Earth. For years, astronauts have painstakingly cultivated delicate crystal growth studies, nurtured biological samples, and meticulously prepared materials science investigations, all with the goal of bringing those results back to Earth for analysis. The journey home, however, is a perilous one, and the handoff between spacecraft is a moment of extreme vulnerability where decades of careful planning can vanish in an instant. The process typically involves loading the finished experiment samples into special transfer bags or hardened containers, which are then passed through an airlock from the station to a waiting spacecraft, like a SpaceX Dragon cargo vehicle or, in the past, a space shuttle payload bay. It is during this delicate ballet of moving objects through hatches in bulky pressurized gloves that accidents can happen. A latch might not be fully secured, a tether could snag and release, or a container might simply be placed on a temporary hold down that fails. In the microgravity environment, that's all it takes. A container holding months of research can silently break free, drifting away from the airlock to become a new, tragically ironic piece of space debris. The types of samples lost in this way read like a catalog of cutting-edge science. There have been biological experiments containing proteins or viruses grown in space, their perfectly formed crystalline structures now forever lost, tumbling end over end instead of being analyzed under a microscope. Materials science investigations, where metals or alloys were melted and resolidified in weightlessness to create novel compounds with unique properties, have met the same fate. Perhaps most haunting are the lost biological samples. Experiments designed to study the effects of radiation and microgravity on living cells, or even on small plant seeds, represent a significant investment of time and international collaboration. These samples aren't just data points. They are physical manifestations of questions we are trying to answer about long-term space travel and the fundamental nature of life itself. The loss is more than just financial. It represents a setback in our understanding. Some of these experiments cannot be easily repeated, as they relied on a specific orbital configuration or a unique moment in the solar cycle. The knowledge they contained is gone, floating just out of reach, a constant and silent reminder of the razor-thin margin for error in space operations. These lost samples are ghost experiments, their potential conclusions forever unknown, their containers now serving as miniature tombs for discoveries that might have been. They underscore a profound truth about exploration, that the pursuit of knowledge is often accompanied by the risk of losing it, and that some of the most frustrating objects in orbit are those that contain the answers to questions we are still struggling to ask. While we often think of the things we've sent into space, some of the most peculiar objects have been there for billions of years, shaped by forces far beyond human engineering. Orbiting the rust-red plains of Mars is one such natural wonder. A lumpy, scarred, and profoundly strange moon that looks less like a celestial body and more like a celestial potato. This is Phobos, the larger of Mars' two moons, and it is a world of captivating mysteries and violent history. Unlike our own majestic moon, Phobos is a tiny, irregular rock, measuring only about 17 miles across at its widest point. It doesn't have enough mass to pull itself into a neat spherical shape, so it remains a misshapen, cratered world, a captured asteroid forever tumbling in its close, swift orbit around the red planet. The most striking feature on its surface is the enormous Stickney crater, a massive impact scar that spans nearly half the moon's diameter. The collision that created Stickney was so titanic that it must have come perilously close to shattering Phobos completely. Imagine the force required to leave a scar that large on such a small body. It's like a bullet grazing a pebble and nearly blowing it to dust. The impact didn't just leave a hole. It sent seismic shockwaves racing across the entire moon, fracturing its interior and sculpting its very shape. But Stickney is just the beginning of the story. Covering vast portions of Phobos are a series of mysterious, parallel grooves. These long, shallow trenches stretch for miles, some as wide as a football field, creating a strange, striated pattern across the landscape. For decades, astronomers debated their origin. One prevailing theory suggests they are fracture lines from the Stickney impact, the deep-seated cracks in the moon's foundation revealed on its surface. Another, more dynamic theory proposes they are the result of tidal forces. Phobos orbits so close to Mars, closer than any other moon to its planet in the solar system, that the gravitational pull of Mars is literally tearing it apart. These grooves could be the stretch marks of a world under immense stress, the first signs of its eventual destruction. And that destruction is the final, fateful chapter in the story of Phobos. Its orbit is not stable. It's slowly, inexorably spiraling inward toward Mars. In about 50 million years, it will cross a boundary known as the Roche limit. This is the point where a planet's gravitational tide becomes stronger than the gravitational force holding a moon together. Once Phobos crosses this line, the relentless pull of Mars will overcome the weak gravity that binds the moon's rubble pile interior. Phobos will be torn asunder, shattered into a million pieces. For a time, Mars will have a magnificent, sprawling ring system, a glittering band of debris encircling the equator, a temporary tombstone for its former companion. Eventually, over millions more years, those fragments will rain down onto the Martian surface in a slow-motion shower of meteorites. Phobos is a living, or rather dying, demonstration of orbital mechanics, a moon with an expiration date, reminding us that even the seemingly permanent features of our solar system are in a constant state of flux, bound by the immutable laws of physics that govern everything from the smallest asteroid to the largest galaxy. This desire to leave a permanent mark among the stars extends beyond the living, reaching into our most profound human rituals of remembrance. For many, the ultimate final resting place is no longer a plot of Earth, but the infinite expanse of space itself. A growing number of companies now offer the service of launching a portion of a loved one's cremated remains into orbit, onto the lunar surface, or even on a one-way journey into the depths of the solar system, transforming memorials into a truly celestial experience. This practice turns the void of space into a cosmic cemetery, where the departed become eternal travelers among the planets and stars they once gazed upon from below. One of the most poignant and famous examples of this is the journey of Clyde Tombaugh, the astronomer who first discovered Pluto in 1930. Tombaugh had always expressed a wish to see the distant world he had found, but the technology to send a spacecraft there simply didn't exist in his lifetime. After his passing in 1997, a portion of his ashes were placed aboard a pioneering NAS, a mission that would, at long last, grant his wish. The New Horizons spacecraft, launched in 2006, carried a small canister bearing his remains. In July 2015, after a journey of nearly 3 billion miles and 9.5 years, New Horizons made its historic flyby of Pluto, finally bringing Tombaugh's ashes to the world he had discovered. An inscription on the container reads, "Interned herein are remains of American Clyde W. Tombaugh, discoverer of Pluto and the solar system's third zone." In a beautiful and poetic twist, his ashes are now continuing on past Pluto, deeper into the Kuiper belt, the very region of the solar system his work helped to define, making him a permanent explorer of the frontier he helped to map. But memorial flights aren't reserved solely for legendary scientists. Commercial companies like Celestis and Elysium Space have made space burial accessible, launching the ashes of hundreds of individuals on a variety of missions. Some are placed on satellites that remain in orbit around Earth for years before eventually re-entering the atmosphere in a final, fiery tribute. Others are sent on more ambitious voyages. The cremated remains of Star Trek creator Gene Roddenberry and several cast members, including James Doohan, who played Scotty, were launched into space, a fitting tribute for those who inspired millions to dream of the stars. Their remains have since returned to Earth, but others continue their journey. Some missions have even aimed for the ultimate destination, a permanent resting place on the surface of the Moon. In 1998, NASA's Lunar Prospector mission carried the ashes of planetary geologist Eugene Shoemaker to the Moon, where they remain forever after the spacecraft was intentionally crashed into the lunar South Pole. This practice, while beautiful to many, is not without its ethical and practical controversies. Some within the scientific community and among various cultures question the appropriateness of depositing human remains on other celestial bodies, viewing it as a form of contamination or a disrespectful act toward worlds that should be preserved for purely scientific study. There are also concerns about the long-term implications, as these memorial capsules, though small, officially become human-made space debris, adding to the catalog of objects we must track. Yet, for the families who choose it, the meaning is profound. It represents the ultimate form of letting go and reaching for the heavens, a promise that a part of their loved one will achieve a kind of immortality, forever sailing the solar winds and gazing down upon the beautiful blue marble we call home. These floating memorials are perhaps the most personal artifacts we have placed in space, each one a story, a life remembered, and a soul set free to wander the cosmos for all eternity. Floating alongside the ghostly remains of memorials and lost experiments are objects sent aloft with a much more specific and scientific purpose, yet their final moments create a spectacle of unexpected beauty. These are the high-altitude research balloons, massive envelopes of thin plastic or latex filled with helium or hydrogen, designed to carry sensitive instruments dozens of miles up to the very edge of space. Their mission is to sample the thin air, measure cosmic rays, or observe the Earth from a vantage point higher than airplanes can fly but lower than satellites orbit. But when their work is done, their demise is not a silent bursting of a party balloon. It is a final, elegant performance in the alien theater of the upper atmosphere. As these balloons ascend, they are governed by a simple principle. The gas inside expands as the outside atmospheric pressure drops. The balloon, often starting no larger than a small car when launched from the ground, can inflate to the size of a football stadium as it climbs into the stratosphere. This immense, gossamer thin sphere is straining against its own limits, a giant bubble of gas surrounded by a plastic skin no thicker than a sandwich bag. It is here, at the apex of its journey, often over 100,000 feet above the Earth, that the environment becomes utterly surreal. The air is so thin it is practically a vacuum. The sky above is not blue but a profound, star-filled black, and the curvature of the Earth is clearly visible below. In this near-space environment, the laws of physics seem to play out in slow motion. When the balloon can expand no further, it bursts, but this is not a simple pop. The rupture is a graceful, almost deliberate failure. A tear begins in the incredibly taut skin, and in the absence of strong atmospheric pressure, the opening propagates slowly. The escaping gas doesn't just vanish. It can create temporary, shimmering vortex rings or delicate plumes that catch the sunlight. For a few moments, the immense shredded plastic envelope, now released from its gaseous heart, begins its long fall back to Earth. But it doesn't simply drop. In the wispy upper air, the huge, rippling sheets of plastic descend with a surreal, languid grace. They twist, flutter, and undulate in the silent sunlight, performing a silent, slow-motion ballet against the backdrop of the black cosmos above and the blue planet below. To instruments on the ground or on the payload itself, this erratic, gentle motion can look like a strange, spectral dance. This dancing is a direct result of the extreme conditions. With minimal air resistance, the pieces of the balloon are subject to tiny currents and temperature gradients, causing them to pirouette and drift in ways that would be impossible in the thicker air below. The sun's rays provide a slight photophoretic force, pushing on the dark and light sides of the plastic with minute differences in energy, adding to the unpredictable motion. For the scientists, the balloon's dance signals the end of data collection, but for anyone who might witness it, though it is incredibly rare to see with the naked eye, it would be a breathtaking and puzzling sight. A silent, glinting entity performing a final, beautiful waltz at the edge of space before the increasing pull of the atmosphere eventually gathers it up and carries the remnants back to the ground, often hundreds of miles from where the journey began. The construction of China's Tiangong space station, a monumental achievement in orbital engineering, has not been without its own contributions to the growing cloud of orbital debris, echoing similar incidents from the International Space Station's history. During a series of complex extravehicular activities, or spacewalks, undertaken to assemble and service the new station, Chinese astronauts, known as takenauts, have experienced the same heart-stopping moment of watching essential tools drift silently away into the void. Much like their international counterparts, these incidents underscore a universal truth of working in microgravity, where the simple act of handling equipment carries inherent risk, regardless of the nation or program involved. One such event was captured on camera during a spacewalk in July 2021. As two takenauts worked outside the Tian core module, a small, handheld tool used for maintenance and installation became untethered. The footage shows the object slowly pivoting away from the astronaut's grasp, a small but stark reminder of the challenges faced outside the spacecraft. While the Chinese Space Agency downplayed the significance of the loss, stating the tool was not critical to completing the mission's primary objectives, the object itself was immediately catalogued by international space surveillance networks. It joined the hundreds of thousands of tracked debris items, each one a potential hazard due to its incredible orbital velocity. The environment around Tiangong is particularly sensitive, as it orbits at a similar altitude to the International Space Station, placing it in one of the most densely populated and valuable regions of low Earth orbit. Every new piece of debris, whether a lost screwdriver, a stray bolt, or a fragment from an old satellite, increases the overall risk of a catastrophic collision. Space agencies around the world, including China's, maintain elaborate models to predict close approaches and must occasionally maneuver their stations to avoid potential impacts. A lost tool, while small, contributes to this background risk, a tiny but tangible addition to the collective challenge of keeping the orbital environment safe for all. These incidents highlight the relentless difficulty of even the most routine procedures in space. The takenauts, clad in their Phaeton spacesuits, must manipulate complex tools while anchored by their feet, all while managing tethers, communicating with ground control, and navigating the overwhelming sensory experience of floating above the Earth. A momentary lapse in attention, a tether hook that wasn't fully secured, or a mechanism that fails can result in the permanent loss of hardware. Each floating wrench or stray instrument becomes a silent testament to the immense precision required for this work and the shared vulnerability of all human operators in the vacuum of space. The story of China's space station construction is ultimately one of incredible success, but it is also a story that now includes its own chapter in the long, ongoing narrative of objects we have accidentally set adrift. Now, just when we think we've seen all the oddities that orbital mechanics and cosmic chance can provide, the universe reveals a structure so whimsically familiar it feels almost like a joke, a hamburger floating in the void. This is no discarded astronaut meal, but a spectacular and strange cosmic nursery known as a protoplanetary disk, and one in particular has earned the delicious nickname of the space hamburger. The star at the center of this story is named IRS-48, located about 440 light-years away in the constellation of Ophiuchus. Like all young stars, it is surrounded by a vast, rotating disk of gas and dust, the raw material from which planets are born. For decades, astronomers have pictured these disks as smooth, flat, homogeneous platters, like a vinyl record spinning around a central spindle. But with the revolutionary power of the Atacama Large Millimeter/Submillimeter Array, or ALMA, we've discovered that these nurseries are far from simple. They are dynamic, structured, and sometimes strangely shaped. The disk around IRS-48 isn't smooth at all. Instead, it presents a stunning and clear three-layered structure. Two bright, symmetrical buns of dust separated by a dark lane of relatively empty space, creating an almost perfect likeness to a classic hamburger suspended against the blackness of space. The formation of this cosmic meal is a fascinating tale of physics and celestial mechanics. The key ingredient isn't beef, but dust, tiny particles of silicon and carbon no larger than grains of sand. In a typical protoplanetary disk, these dust grains should be evenly distributed. But IRS-48 is not typical. Astronomers believe a young, newly formed planet is orbiting within the disk, its gravity carving out a vast, circular gap and acting like a shepherd, herding the larger dust grains into a specific, confined region. This process creates a dense, asymmetric trap, a pressure bump where dust particles can accumulate and clump together. As the disk spins, this trapped dust is forced into a specific, narrow band, piling up into two thick, bright rings on either side of the star. From our vantage point on Earth, we see this ring edge on, and the geometry does the rest. The star itself, the hot cosmic grill at the center, is hidden from our direct view by the thick, dense dust in the central plane of the disk. This creates the dark band, the patty region of the hamburger, while the light from the star illuminates the upper and lower surfaces of the dust trap, making them glow brilliantly and appear as the two halves of the bun. What makes the space hamburger so much more than a celestial curiosity is what's happening inside that dust trap. This is not a static structure. It's a planet-making factory. Within those dense bun-like rings, the conditions are perfect for the next step in planet formation. Dust grains are safe there, able to gently collide and stick together, growing from tiny specks into pebbles, then rocks, and eventually the building blocks of full-fledged planets, a process known as pebble accretion. The IRS-48 system provides us with a rare and invaluable laboratory to observe this critical stage of planetary birth in action. It offers a direct test of our theories about how tiny particles overcome the tendency to just spiral into the star or get blown out by stellar winds, and instead manage to gather together to form new worlds. This bizarre hamburger shape is therefore a snapshot of creation itself, a temporary phase in the multi-million-year process of building a solar system. It shows us that the paths to planet formation are not always smooth and orderly, but can be sculpted by gravitational interactions into wonderfully odd and unexpected forms, proving that even in the vast, impersonal cosmos, there's still room for a little bit of whimsy and a familiar shape to help us understand the unfamiliar. But this ever-growing cloud of debris isn't just the result of accidental losses. Some of its most dangerous and numerous members were born from moments of catastrophic, high-speed violence. On February 10, 2009, a routine flicker of data on a screen signaled an event that would permanently change how we manage the space around our planet. An active American communications satellite, Iridium-33, was orbiting at over 17,000 miles per hour, on a nearly perpendicular path, traveling at a similar breathtaking speed, was the defunct Russian military satellite Cosmos 2251. Hurtling through the void, these two objects, one functioning and one a ghost from the Cold War, occupied the same precise point in space at the exact same moment. The collision was instantaneous and absolute, a hypervelocity impact that released energy equivalent to the detonation of several tons of TNT. Iridium-33 and Cosmos 2251 didn't just break apart. They vaporized, disintegrating into a vast, expanding cloud of shrapnel. In that single moment, the number of trackable objects in Earth's orbit increased by an estimated 10%. The U.S. Space Surveillance Network immediately began cataloging the debris, which initially consisted of over 2,200 large fragments, each one large enough to be tracked by radar. But the true number of dangerous particles is far, far greater. When you include the countless tiny, untrackable shreds of metal, shattered solar panel glass, and frozen droplets of coolant and fuel, the number of new debris pieces likely soared into the hundreds of thousands. Each one of these fragments, from a refrigerator-sized chunk of a satellite bus to a fleck of paint no larger than a sand grain, became a new, independent satellite, each following its own chaotic and unpredictable path around the Earth. This wasn't a simple cloud. It was a shotgun blast of high-velocity shrapnel that instantly populated a heavily used orbital region with an immense new field of hazards. The fragments themselves are a bizarre and twisted testament to the forces involved. Unlike the neat, boxy satellites they came from, this new debris is composed of jagged, shredded aluminum, torn composite materials, and mangled pieces of electronics, all frozen into strange, angular shapes. Some are flat, rotating panels that flash brilliantly as they tumble. Others are dense, crumpled knots of metal that are far darker and harder to track. Many are coated with frozen liquids, hydrazine fuel or ammonia coolant, that leaked out during the disintegration, making them not just physical threats but potential chemical hazards as well. Each piece carries with it the story of that violent collision, a permanent, tumbling reminder of the immense kinetic energy unleashed when two objects meet at orbital velocity. The long-term consequences of this single event are still unfolding today, over a decade later. The debris cloud from the Iridium-Cosmos collision did not stay in a neat cluster. It has since spread out, diffusing into a wide band that intersects the orbits of hundreds of operational satellites, including the International Space Station. This event served as a terrifying wake-up call for the world's space agencies and commercial operators. It proved that a single collision could trigger a cascading chain reaction known as the Kessler syndrome, where the debris from one impact causes more collisions, which in turn create even more debris, potentially rendering entire orbital altitudes unusable for generations. Every time the ISS or another valuable satellite has to perform a maneuver to avoid a piece of debris, there is a high probability that the object in question is a fragment from that 2009 collision. These strange, twisted pieces of metal are more than just junk. They are the first artifacts of a new, unintended chapter in the space age, a permanent and growing monument to the fact that our greatest threat in orbit may no longer be the vast emptiness of space, but the crowded and dangerous field of our own making. And while some structures are born from the gentle drift of dust, others are forged in the final, violent throes of a dying star, a stellar death that can create some of the most breathtakingly beautiful and intricate formations in the entire cosmos. One of the most spectacular examples of this celestial artistry is the so-called space butterfly, officially known to astronomers as the Bug Nebula or NGC 6302. Located roughly 3,800 light-years away in the constellation Scorpius, this object is a planetary nebula, a name that is a complete misnomer from its early discovery. It has nothing to do with planets and everything to do with the dramatic end of a star's life. What we see is the final exhalation of a sun-like star, its outer layers expelled into space in two magnificent, wing-like lobes of glowing gas that stretch for over 3 light-years from tip to tip. To put that immense scale into perspective, if you could place this cosmic insect at the center of our solar system, its wings would extend well beyond the orbit of Pluto. The butterfly shape, known scientifically as a bipolar nebula, is the result of a complex and violent stellar dance. At the very heart of this nebula, hidden from direct view by an incredibly dense, dusty waistband, lies one of the hottest white dwarf stars ever discovered. This is the exposed, superheated core of the original star, now a tiny, Earth-sized ember burning at an almost incomprehensible 250,000 degrees Celsius. That is over 40 times hotter than the surface of our own sun. This ferocious stellar engine is the power source for the entire display, its intense ultraviolet radiation causing the vast clouds of ejected gas to fluoresce with brilliant colors. Oxygen glows blue-green, while nitrogen and hydrogen create the striking red hues. The intricate patterns within the wings are not random. They are a fossil record of the star's death spasms. Rather than shedding its atmosphere in a simple, expanding sphere, this star did so in a series of intense, episodic outbursts, creating the delicate, filamentary structures that look like veins in a butterfly's wing. But what created such a perfectly symmetrical, bipolar shape instead of a random sphere? The prevailing theory points to the influence of a binary companion. Astronomers suspect the central star was not alone. It likely had a smaller partner orbiting closely around it. As the dying star began to expand into its red giant phase, its companion star may have been engulfed, spiraling inward through the outer layers. This chaotic gravitational dance would have acted like a blender, spinning the ejected material and funneling it outwards from the star's poles at tremendous speeds, creating the two opposing jets that formed the magnificent wings we see today. Alternatively, the star's own immensely powerful magnetic fields could have channeled the outflowing gas, sculpting it into this distinct shape. The dense ring of dust and gas obscuring the central star is the leftover debris from this catastrophic transformation, a torus of material that pinches the outflow and enhances the butterfly illusion. The entire system is a monument to transience. The beautiful, glowing gas clouds are expanding into the void at speeds of over 600,000 miles per hour, and in a mere few thousand years, a blink of an eye in cosmic terms, they will have dispersed and faded to invisibility, leaving behind only the lonely, fading white dwarf to cool for eternity. The space butterfly is therefore a fleeting masterpiece. We are witnessing a single, glorious frame in a cosmic film that has been playing for millennia, a final, explosive burst of beauty and color from a star that refused to fade away quietly. It serves as a poignant reminder of our own sun's eventual fate, a preview of the beautiful and violent death that awaits it billions of years from now, and a stunning demonstration that even in death, a star can create something of breathtaking, winged wonder. While we've marveled at the grand and the strange, from interstellar visitors to cosmic butterflies, perhaps the most pervasive and insidious form of space debris is also the smallest and most mundane. Drifting unseen through the orbital highways are countless nuts, bolts, washers, screws, and clamps. The tiny, fundamental pieces of hardware that hold our grandest spacefaring machines together, only to be lost to the void during the delicate and dangerous work of assembly and repair. Each one is a story of a momentary lapse, a tool slipping, or a latch not quite catching. And together they form a silent, high-speed shrapnel cloud that represents one of the most persistent threats to our continued presence in space. The process of building and maintaining structures like the International Space Station is an exercise in managing immense complexity under extreme pressure. Astronauts, working in bulky pressurized gloves with limited dexterity, must manipulate these small metal objects while secured by nothing but their feet to a work platform. A standard procedure might involve removing a dozen fasteners to access a panel, placing each one carefully into a sealed container or bag. But in the microgravity environment, there is no such thing as a stable surface. A bag can bump against a handrail, its latch jarring open. A momentary distraction can lead to a bolt being placed on a temporary magnetic hold that isn't as secure as believed. A single errant nudge is all it takes to send a tiny piece of hardware on a one-way trip, drifting away with a slow, steady motion that is impossible to stop. There's no gasp, no clatter. Just the silent, heart-sinking realization that a piece of the spacecraft is now permanently missing. These losses are not rare occurrences. They are a documented and accepted occupational hazard of spacewalking. Over the decades of the ISS program and the Space Shuttle missions before it, hundreds of these small items have been lost. NASA and other space agencies meticulously log every incident, adding the object to the growing catalog of orbital debris. The official designation might be something clinical and impersonal, like Object 2024-007b, but it represents a very real and tangible failure in procedure, a tiny crack in the perfect execution required to survive in orbit. Each lost fastener is a testament to the immense difficulty of performing even the simplest mechanical task, when every action has an equal and opposite reaction, and there is no gravity to provide a restoring force. The danger posed by these miniature projectiles is wildly disproportionate to their size. A single aluminum nut, massing just a few grams, travels at orbital velocities exceeding 17,000 miles per hour. At that speed, its kinetic energy is comparable to that of a bowling ball dropped from a multi-story building. An impact with a critical component like a pressurized module, a coolant line, or a spacecraft window could be catastrophic, potentially causing a depressurization event or crippling a vital system. The real fear is not a single, large piece of debris that can be tracked and avoided, but the countless untrackable smaller fragments that could be created if one of these fasteners were to collide with another object, spawning a new generation of even smaller, even more numerous and unpredictable bullets. This cloud of lost hardware contributes significantly to the overall debris environment, a statistical risk that mission planners must account for every single day. Yet, in a strange twist of cosmic irony, the very properties that make these objects so dangerous also make many of them self-cleaning over a long enough timeline. Unlike larger objects in higher orbits, these small, dense pieces of metal in low Earth orbit are highly susceptible to atmospheric drag. The tenuous wisps of gas at the edge of space act as a constant brake, slowly sapping their orbital energy. Over months or years, their path around the Earth decays, becoming more and more elliptical until they finally dip into the thicker atmosphere. There, they meet a fiery and final demise, incinerating completely in a brief streak of light, a meteor of human making that no one on the ground will ever see. They are a temporary pollutant, but their constant replacement through new accidents means the threat they pose is forever renewed, a perpetual monument to the hundreds of tiny, human mistakes made in the pursuit of grand orbital ambitions. And while the grand ballet of orbital construction continues, another kind of performer makes its debut with each journey to the International Space Station, a silent, automated dragon that briefly soars among the stars before its fiery farewell. This is the unpressurized trunk of SpaceX's Crew Dragon capsule, a critical but often forgotten component of the spacecraft that has a surprising second act after its primary job is done. When a Crew Dragon launches, it's a two-part vehicle: the sleek, pressurized capsule where the astronauts live and work, and the boxy, unpressurized trunk attached to its base. This trunk serves as the spacecraft's backbone and utility module during the ascent, providing structural support and housing the two large solar arrays that unfurl like wings to power the journey. Its most vital role, however, is thermal. Its white skin is covered in radiators that dissipate the immense heat generated by the electronics inside, preventing the capsule from overheating. Once the Dragon capsule arrives at the space station and docks, the trunk's work is essentially finished. The capsule itself, with the astronauts and any time-sensitive cargo, is the only part that enters the station. The trunk remains outside, a silent partner clinging to the station's docking port. It stays there for the entire duration of the mission, which can be months long, acting as a passive piece of hardware until it's time for the astronauts to come home. The moment of separation is the trunk's final bow. As the Crew Dragon capsule undocks and maneuvers away, pyrotechnic bolts fire, cleanly severing the connection between the capsule and its trunk. With a gentle push from springs, the two halves drift apart. The capsule orients itself for re-entry, its heat shield pointing forward to withstand the inferno of atmospheric friction. The trunk, however, is left behind. It has no heat shield, no propulsion, and no guidance system. It is now an independent, dragon-shaped object adrift in orbit. And what a distinctive shape it is! From certain angles, the trunk's form is remarkably evocative of its mythological namesake. The main cylindrical body, with its textured white and black panels, could be seen as the creature's long torso. The two solar array wings, now folded back against its sides after being retracted for re-entry, might be interpreted as folded wings or legs tucked close. The most striking feature, however, is the nose. The forward bulkhead of the trunk, which was attached to the capsule, is not a flat surface. It is a complex, geometric pattern of bays and mounting points, and when sunlight hits it at a sharp angle, it can create deep shadows and highlights that look uncannily like a stylized, angular dragon's head with an open maw, as if silently roaring into the void. This unintended celestial Rorschach test, a product of pure engineering necessity, becomes a temporary piece of orbital art. Its life as an independent satellite is a short but carefully tracked one. Mission controllers immediately add it to the catalog of space debris, monitoring its path to ensure it doesn't pose a risk to other spacecraft. Tumbling slowly, the trunk is subject to the faint but persistent drag of the upper atmosphere. Over a period that typically lasts a few months, this drag steadily reduces its velocity, causing its orbit to decay. It dips lower and lower until it finally reaches the denser layers of the atmosphere. The end is both violent and beautiful. Traveling at over 17,000 miles per hour, the aluminum and carbon composite structure cannot withstand the intense heat of re-entry. It fractures, melts, and vaporizes in a brilliant but brief fireball high over an uninhabited region of ocean, its constituent atoms scattering into the winds. Each trunk's journey is a perfect microcosm of the spaceflight life cycle, a critical role in a grand mission, a peaceful, silent retirement in orbit, and a final, complete disposal that leaves no trace behind, ensuring the roads to space remain clear for the next Dragon to fly. But for every object with a public and celebrated purpose, there exists a shadow fleet in the sky, objects launched in absolute secrecy that defy easy explanation and fuel intense speculation. These are the mysterious rocket upper stages that enter orbit and simply stay there, for months or even years, performing no obvious function and carrying payloads whose nature is a closely guarded state secret. Unlike the spent stages that tumble and flash predictably, these objects often exhibit unnervingly controlled behavior, making tiny, precise maneuvers that suggest they are anything but inert debris. They are the blank slates upon which conspiracy theories and legitimate security concerns are written, a constant reminder that Earth orbit is not just a scientific frontier, but the world's ultimate high ground for espionage and military strategy. The story often begins with a public announcement of a routine satellite launch. A rocket blasts off, and the world is told it is carrying a communications satellite or a weather observation platform into a specific orbit. Independent satellite trackers, a global network of amateur astronomers and enthusiasts with surprisingly sophisticated equipment, train their telescopes and radar on the expected location. Often, they find exactly what was announced, but sometimes the findings are deeply anomalous. Instead of a single new satellite, they detect the rocket's upper stage, the part of the vehicle that should have released its payload and then been deorbited or sent into a harmless graveyard orbit, still hanging in space, seemingly active. Even more curiously, they sometimes find multiple new objects associated with this stage, suggesting it has deployed not one, but several smaller, undisclosed satellites. The behavior of these objects is what truly sets them apart from normal space debris. An inert rocket body left to the whims of physics will tumble chaotically. But these mysterious stages are often remarkably stable, maintaining a fixed orientation relative to the Earth or the Sun. This stability is a clear indicator of an active attitude control system. Small thrusters on board are firing periodically to keep the object pointed in a specific direction. This requires power, which implies functioning solar panels and a charged battery. Most damningly, orbital tracking data over time sometimes reveals that these objects perform small but distinct orbital adjustments. They might raise their altitude slightly or shift their inclination by a tiny fraction of a degree, maneuvers that require fuel and a guidance system. This is not the behavior of a piece of junk. It is the signature of a functioning spacecraft with a mission, and that mission is almost certainly classified. So what are they? The most accepted theory within the defense and intelligence community is that these are covert orbital inspection vehicles, often referred to as inspector satellites, or more ominously, space stalkers. Their suspected purpose is to clandestinely approach and observe other nations' valuable or secretive satellites. They could be equipped with high-resolution cameras, signals intelligence antennas to eavesdrop on data transmissions, or other sensors to analyze the electronic emissions and physical characteristics of their targets. This allows a country to gather intelligence on the capabilities of an adversary's spy satellites, communications networks, or early warning systems without ever declaring their intent or admitting the satellite's existence. In a sense, they are unmarked police cars in the orbital highway, silently shadowing their targets and taking notes. Another compelling possibility is that these mysterious payloads are technology testbeds for new and radical space-based systems. The relative secrecy of a classified rocket launch provides the perfect cover to test advanced new sensors, exotic propulsion methods, or stealth coatings designed to make a satellite harder to detect. By hiding these experiments inside what appears to be a simple rocket stage, a nation can conduct risky or provocative research without public scrutiny or triggering an immediate diplomatic incident. The stage itself provides power, stability, and a platform, making it an ideal temporary host for such experiments before the technology is matured and deployed on a dedicated, operational spacecraft. The most chilling speculation, though rarely confirmed, involves systems with more active capabilities. Some analysts worry that a few of these vehicles could be prototypes for co-orbital anti-satellite weapons platforms designed not just to observe, but to disable or destroy other satellites on command. They could be equipped with robotic arms for physical interference, jammers to block signals, or even kinetic kill vehicles. The line between an inspector satellite and a weaponized one can be very thin, and the ambiguity itself is a powerful tool of deterrence and psychological operation. The mere presence of an unmarked, maneuverable object lurking near a multi-billion-dollar spy satellite sends a clear, if unspoken, message. We can see you, we can reach you, and we have the capability to interfere with you. These enigmatic objects represent the dark, silent side of the space age. They transform the orbital environment from a realm of open scientific inquiry into a theater of shadows and unspoken threats. Every time one of these empty-looking stages performs a tiny, fuel-burning maneuver, it is a silent declaration that the competition for dominance extends far beyond our atmosphere. They are the ultimate sleeper agents of space, hiding in plain sight, their true purpose known only to a select few on the ground, a permanent and unsettling reminder that the final frontier is not immune to the oldest human pursuits of secrecy and power. Gazing back at us from 700 light-years away in the constellation, Aquarius is one of the most hauntingly beautiful and perfectly familiar shapes in the entire cosmos, the Helix Nebula. Through the lens of a powerful telescope, it doesn't look like a cloud of gas. It looks like a giant, unblinking eye staring out from the depths of space, its intricate, colorful iris surrounding a deep, dark pupil. This celestial eyeball, officially catalogued as NGC 7293, is not a portent of some cosmic entity watching us, but the breathtakingly beautiful funeral shroud of a sun-like star, a planetary nebula, that offers us a prophetic glimpse into our own solar system's fate billions of years from now. The story of the Helix begins with a star not unlike our own Sun, a main sequence star that spent billions of years burning hydrogen in its core in a stable, predictable fashion. But as it reached the end of its life, it exhausted its core fuel and began to die. It ballooned outward into a red giant, becoming hundreds of times its original size. In this unstable phase, it began to pulse, shuddering violently and ejecting its outer layers into space in a series of intense, episodic outbursts. What we see as the iris of the eye is this expelled stellar material, a vast cloud of gas and dust that has been blown outward over thousands of years. The central star, now exposed, is a white-hot white dwarf, the incredibly dense, Earth-sized core that remains. This stellar ember, blazing at over 100,000 degrees Celsius, is the pupil at the center of the eye. Its intense ultraviolet radiation acts like a cosmic blacklight, causing the surrounding cloud of hydrogen gas to fluoresce with a brilliant pinkish-red glow, and the oxygen to glow a vivid blue-green, creating the ethereal colors of the cosmic iris. But the true, mesmerizing complexity of the Helix's structure lies in details that were only revealed by the Hubble Space Telescope. What from a distance looks like a smooth disk resolves into a breathtaking collection of thousands of individual, comet-like knots. Each of these knots is a colossal structure in its own right, a gaseous head the size of our entire solar system, trailed by a faint, glowing tail that stretches for 100 billion miles. Astronomers believe these knots form during the final death throes of the star. As the ejected material expands and cools, denser, more resilient pockets of gas and dust are left behind, while the fierce stellar wind and radiation from the white dwarf sculpt and erode them, carving out the globules and blowing the less dense material away to form the long, streaming tails. These knots are more than just a beautiful detail. They are the mechanism by which the star's enriched elements carbon, oxygen, and nitrogen are returned to the interstellar medium. Over the next several thousand years, these cosmic tadpoles will slowly dissipate, seeding the surrounding space with the very building blocks for new stars, planets, and potentially future life. The helix eye is not just watching the universe. It is actively participating in its cycle of death and rebirth, a vital part of the cosmic ecology. The illusion of an eye is a perfect example of pareidolia, our human tendency to see familiar patterns in random shapes, but in this case, the geometry is almost too perfect to be believed. We are seeing the nebula almost perfectly face-on, looking directly down the barrel of a nearly spherical shell of gas. The dark center isn't empty space. It is a tunnel of clearer vision leading back to the brilliant central star. The ring we perceive as the iris is actually the brighter, denser rim of a vast, three-dimensional bubble. If we could fly around and view it from the side, it would likely appear more like a double-lobed hourglass structure, similar to the Butterfly Nebula. Our privileged head-on perspective transforms this complex, multi-dimensional object into a singular, iconic image. This incredible view provides astronomers with an unparalleled laboratory to study the death of solar mass stars in minute detail, offering clues about the chemical enrichment of our galaxy and the eventual, inevitable destiny of our own sun. The Helix Nebula is a masterpiece of deep time, a fleeting structure that will continue to expand and fade over the next 10,000 years until it vanishes from view entirely, leaving only the cooling white dwarf behind. It is a poignant and beautiful reminder that even in the cold equations of stellar evolution, there can exist a profound and eerie beauty, a final glance from a dying star that reflects our own world's distant future. These shimmering, temporary clouds represent a more systemic and concerning form of pollution, born not from a simple mistake during a spacewalk, but from the gradual decay of the complex machinery we've placed in orbit. Many older satellites and even some modern ones rely on sophisticated cooling systems to regulate their internal temperature, preventing sensitive electronics from overheating in the intense, unfiltered sunlight of space. These systems often use liquid ammonia or other specialized coolants, circulating them through a network of pipes and radiators. Over decades of service, however, these systems can fail. A tiny micrometeoroid impact, the fatigue of metal from constant thermal cycling, or the degradation of a seal can create a minuscule crack. From this tiny breach, a high-pressure jet of liquid coolant silently escapes into the vacuum. The moment this stream of liquid meets the emptiness of space, it undergoes a transformation that is both beautiful and problematic. In the absence of atmospheric pressure, the laws of physics as we know them on Earth no longer apply. The liquid coolant doesn't simply drift away. It undergoes rapid flash freezing and violent sublimation simultaneously. This means the liquid particles instantly crystallize into billions of microscopic ice shards, while many of those same crystals immediately turn directly from a solid into a gas, skipping the liquid phase entirely. This chaotic process acts like a natural sprayer, creating an expanding, glittering cloud of ice particles that continues to trail behind the ailing satellite. From a distance, the effect is stunning. The sun, positioned just right, illuminates this man-made cloud, making it glow with an intense, brilliant white light. Each tiny ice crystal acts as a perfect mirror, reflecting the sunlight and creating the illusion of a temporary, miniature nebula wrapped around the satellite. It can appear as a faint, ethereal halo or a more defined, shimmering plume, depending on the size of the leak and the rate of discharge. For a brief period, a malfunctioning piece of human technology becomes the heart of its own celestial spectacle, a ghostly aura of ice and light. But this beauty belies a significant threat. This cloud of ice particles does not simply dissipate harmlessly. Each individual crystal, though microscopic, is now an independent piece of space debris, traveling at orbital velocity. While many of the smaller particles will eventually be slowed by the faint drag of the upper atmosphere and burn up, larger chunks can persist for months or even years. They form a diffuse, unpredictable shroud around the satellite's orbital path, increasing the collision risk for other spacecraft operating at that altitude. A single gram of ice, moving at 17,500 miles per hour, carries enough kinetic energy to pit deep craters into solar panels or puncture a pressurized module. These accidental ice clouds are a clear example of how even the most carefully designed systems can, over time, become unintended contributors to the growing debris problem, creating zones of hazard that are as beautiful as they are dangerous. While some celestial objects announce their presence with brilliant clouds of glowing gas, others reveal themselves by the profound absence of light, casting in sky-black silhouettes against the starry canvas of the Milky Way. Such is the case with one of the most perfectly defined and strangely familiar dark nebulae in our sky, Barnard 68. Floating in the constellation Ophiuchus, approximately 500 light-years from Earth, this object appears as a nearly perfect, opaque black hole in the fabric of the galaxy. But this is no empty void. It is an incredibly dense, cold cloud of gas and dust, so thick that it completely blocks the light from the hundreds of thousands of stars that lie behind it. And from our perspective, its shape is unmistakable, a solitary, celestial banana drifting through the interstellar night. This cosmic fruit is what astronomers call a Bok globule, a specific type of dark nebula characterized by its high density and relatively small size. Barnard 68 is a compact pocket of molecular hydrogen gas and interstellar soot, with a mass roughly twice that of our Sun, all contained within a region of space not much larger than our solar system. The temperatures inside this cloud are unbelievably harsh, but not in the way we usually think. They hover just a few degrees above absolute zero, the theoretical point where all molecular motion ceases. This extreme cold is the key to its existence. The frigid temperatures allow the gas molecules to move slowly enough that the cloud's own weak gravity can overcome the internal gas pressure that would otherwise cause it to dissipate. It is a self-gravitating entity held together by its own mass, a dark island of potential adrift in space. What makes Barnard 68 so captivating to scientists is not just its current state, but its future. This Bok globule is a stellar nursery in waiting, a cocoon of raw material on the verge of a spectacular transformation. The cloud is currently in a precarious state of equilibrium, with its inward pull of gravity perfectly balanced by the outward push of its internal gas pressure. But this balance is delicate. A passing shockwave from a nearby supernova, the gentle gravitational nudge of a drifting star, or simply the slow, inevitable process of accretion could be enough to tip the scales. Once that equilibrium is lost, the entire cloud will begin to collapse under its own weight. The process would start slowly, with denser regions within the cloud beginning to pull in more material. As the collapse accelerates, the center of the cloud will become increasingly hot and dense. Eventually, the core temperature will reach millions of degrees, igniting the nuclear fusion of hydrogen and heralding the birth of a new star. The surrounding material will flatten into a spinning protoplanetary disk, from which planets may eventually form. In this sense, Barnard 68 is a frozen moment in time, a snapshot of the quiet, dark peace that precedes the violent and brilliant storm of creation. We are looking at a blueprint for a future solar system, a potential sun and its planets waiting in the wings for their cue to enter the cosmic stage. The near-perfect silhouette of the space banana is also a powerful tool for astronomers. Because it blocks all the light from behind it, scientists can study the cloud's composition in incredible detail by analyzing what wavelengths of light it absorbs. It acts like a colossal filter, allowing researchers to probe the exact types of molecules and dust grains that constitute its structure. This has revealed a complex interior, with a solid core of material surrounded by a gradually thinning outer envelope. Its distinct curved shape is likely the result of complex magnetic fields threading through the interstellar medium, sculpting the cloud over eons. While it appears static to our eyes, it is a dynamic object, slowly evolving and destined to one day vanish, not by drifting away, but by transforming into something, Chinese letter, and luminous, a dark seed that will eventually blossom into light. Perhaps the most heartbreaking losses are not of tools or experiments, but of the small, irreplaceable personal items that astronauts bring with them as tiny reminders of home and loved ones. These objects carry a weight of emotion far beyond their physical mass, and their accidental journey into the void transforms them into the most poignant pieces of space debris imaginable. The most famous of these is likely a wedding ring, lost by astronaut Richard Mike Mullane during a space shuttle mission in the 1980s. The ring had been taped to his underwear to keep it secure, but during the messy process of changing clothes in microgravity, the tape came loose. He describes the heart-sinking moment he saw the ring, a symbol of his marriage and connection to Earth, slowly tumbling away through the mid-deck of the shuttle, completely out of reach. It was a stark, emotional reminder of the vulnerability that exists even inside the spacecraft, where a deeply personal treasure can be lost forever to the same physics that makes spaceflight possible. Mission patches, those embroidered symbols of crew identity and achievement, have also met this fate. During the intense and physically demanding work of a spacewalk, the Velcro and pins securing these patches to a spacesuit can occasionally fail. There are accounts of astronauts watching a small, colorful piece of cloth, representing years of training and the pinnacle of their career, silently drift away from their shoulder, becoming a tiny, lonely flag against the overwhelming blackness. Even simple items like a photograph, a lucky charm, or a small toy brought for a child back home are not immune. In the constant floating environment, a locker door left unsecured or a momentary lapse can send any unanchored object on a one-way trip. These losses are often met with a quiet, personal grief. There is no way to recover them, no procedure to enact a rescue. The astronaut can only watch, a silent witness to the departure of a tangible piece of their earthly life. These objects now form a ghostly archive of human sentiment orbiting our planet. Unlike the sterile, functional debris of shattered satellites or spent rockets, each of these personal items has a story, a name, and a face attached to it. They are accidental time capsules, frozen in the eternal sunset of low Earth orbit. A wedding ring continues to circle the globe, a perpetual vow spoken in silence. A mission patch, designed to commemorate a specific achievement, now represents an entirely different, more human story of fallibility and loss. They serve as a powerful counterpoint to the grand narrative of exploration and machinery, reminding us that at the heart of every mission are people, individuals who carry their loves, their superstitions, and their memories with them into the extraordinary environment of space, and who sometimes, heartbreakingly, leave a little piece of it behind. These aren't just pieces of junk. They are floating, metallic memories, the most human artifacts we have ever accidentally set adrift.